talk about dividing rational expressions. When we divide, just like you did in basic arithmetic many years ago, when you divide fractions, the rule is that, let's say you've got 7/3 divided by 1/2. You keep the first fraction just like it is, and then when you divide, you're going to multiply by the reciprocal of your second fraction. What does reciprocal mean? That just means that you flip it upside down. So 7/3 divided by 1/2 becomes 7/3 times 2/1. Once you have it as a multiplication problem, it's exactly the same steps that you did for the multiplication. If you can reduce something at this point, you want to try to do that. This does not have anything that can be reduced, so I'm just going to multiply straight across the top and straight across the bottom. I get 14/3. Now, you might want to go further with that because 14 is a lot larger than 3, but they don't share any common factors, so this technically is simplified. It could be written as a mixed number, but in algebra, most of the time we prefer to just leave them as improper fractions. So that's it. That's as far as I would take that. Let's look at example 4. In part A, we want to divide 9/2x with 3/x. So we're going to do the same step. We're going to keep the first fraction like it is, and then we're going to multiply by the reciprocal of the second fraction. And now I need to see if I can find anything that can be reduced. Looking this way, the 9 and the 3 have a common factor of 3, so 3 goes into 3 once, 3 goes into 9 3 times. And then this way, you see we've got a common factor of x, so we can cross those out as well. What does that leave me with? My numerator has a 3, denominator has a 2, and a 1, so my answer is 3/2. You might notice that I'm putting an arrow here instead of an equal sign. I do that because I like to go vertically when I'm working through these problems. I don't like to just slap equal signs beside things in algebra because you have to be careful to distinguish between an expression and an equation. There's a huge difference in how they're handled. So it can get very confusing if you start putting equal signs next to things. So I like to go vertically with it, and if I run out of space, I'll just put an arrow for my next step. Example 4b, you'll notice I left you an entire page to work on this one. I don't think it's going to take up that much space though. I don't think it's that bad. What do we need to do first here? You can start by factoring, but personally, my opinion is that anytime I'm dividing fractions, my first step, I want to go ahead and change it to multiplication and take the reciprocal, so I'm done even thinking about that part, and I don't have to worry about forgetting to do it later. It's a super easy step. You might just do it when you copy the problem down. So let's just write it as 4 minus x squared over 6 times 2 over x minus 2. And now what can I do? Can anything be factored? 4 minus x squared needs to be factored. That's a difference of squares. Do you know how that factors? Why don't you pause the video, go ahead and see what you can do with this problem, and then we'll compare. Okay, so let's see if we agree. 4 minus x squared, that's difference of squares. It factors as 2 minus x times 2 plus x. X minus 2 does not factor, so it's just going to be treated as a big factor. So again, we've got this situation where we've got two factors that are almost the same, but they have opposite signs. So we know that we can just reduce these, but replace with a -1, because that -1 would change the signs in one of them. So that leaves me with -1 times 2 plus x times 2 over, and the 2 and the 6 can be reduced, so let's do that. 2 goes into itself once, 2 goes into its 6 3 times. So our answer, so no, it didn't take up a whole page. We're left with the -1, and then in parentheses we've got the 2 plus x, which I'm going to write as x plus 2 because I like that better. And in the denominator, the only thing left is my 3. All right. There is more than one correct way to write this answer, though. The answer that we just got is correct. If it's a multiple choice question on a test, you've got to make sure that you can identify the correct choice. So you could put the negative in front of the fraction, and you could write it as negative and then x plus 2 over 3. You could write it that way. You could also distribute the negative through the numerator, and you could say it's negative x minus 2 all over 3. Okay, so all three of these are correct answers. I probably would not leave the 1 there, though. I'd probably just put a negative in the front. So that answer is fine. Smiley face. This answer is good. And this answer is good. All three of these are good answers. Okay. So let's look at examples of addition and subtraction of rational expressions. These problems tend to get rather large before you finish them. We're definitely going to need to start by finding our common denominator here. We've got x over x minus 1 plus 2x plus 3 over x squared minus 1. How do I find a common denominator with rational expressions? You can think of this as there's a rule that states that, or basically, I guess the definition of least common denominator is that you need to find the product of each factor raised to its highest power. What does that mean? Well, let's factor all of these denominators as far as we possibly can, and then from the factors that we get, we need to use each of those, and if we have anything that's being raised to the second power or the third power, we would need to include that exponent. So it's a lot easier to see it than it is to understand it from my explanation. So let's take a look. My first one, this denominator cannot be factored, so it's going to stay just like it is. And the x minus 1 will we'll think of the x minus 1 as a factor. And in terms of finding our common denominator, we're really not interested in factoring the numerator. We'll want to see what happens when we factor our denominators. Over here, if we factor this, it's going to be x plus 1 times x minus 1. Excuse me. Alright, so now we can see that the factors in our denominator include x minus 1, x plus 1, and then x minus 1 shows up a second time. Well, we just need to make sure that we include every factor that was given to us here. So my LCD is x minus 1 times x plus 1. This is redundant. I don't need another one. So my LCD is x minus 1 times x plus 1. So this is how I need to, my equivalent fraction now is going to come from using that LCD. And I'm going to kind of combine my steps just a little bit. When I was working with just arithmetic, I kept two separate fractions. But because there's so much to write in these problems, I'm going to go ahead and combine the fraction at this point, and then we'll have to simplify it from there. So I'll go ahead and put my LCD in my denominator. So the x minus 1 times x plus 1. My numerator up here, I've got the x already. What do I need to multiply this denominator by to give me this LCD? This denominator is missing which factor? It needs the x plus 1. So I'm going to multiply the numerator by that missing factor, x plus 1. So it's going to go here. Bring down my plus. On this side, this denominator has everything. There's nothing missing from this one. So I don't have to do anything to the numerator. I'm just going to bring it down just like it is. Now we're going to need to distribute and combine like terms in the numerator. Alright, so why don't you pause the video, work on distributing and combining like terms in the numerator, and then think about whether or not it might reduce from there. And I'm going to erase the board and then we can finish it together. So let's see how you did. When you distribute in the top, you're going to have x squared plus x. And then over here, there's nothing to distribute. You're just going to have 2x plus 3. The denominator, I'm going to leave just like it is. It's already factored. My numerator, I can combine x and 2x. So I've got x squared plus 3x plus 3 over x minus 1 times x plus 1. You always need to think about possibly being able to reduce your answer at the end. Look at the trinomial, x squared plus 3x plus 3. Is there any way that we might be able to get that to factor? You've got your a is 1, your c is 3, so you need factors of 3. Well, that would just be 1 and 3, alright? So if you think about possible factors of 3 that you could use to factor your numerator, you would need a pair of numbers that would add together to give you this middle number, 3, and those numbers are not going to do it. So that numerator does not factor. That tells me that everything is already completely reduced, so this is my answer. X squared plus 3x plus 3 all over x minus 1 times x plus 1. Example 5, part B. This time we're subtracting. We still need to factor our denominators and find the LCD. The key difference that you have to be careful of when you're subtracting rational expressions is that you're going to have to distribute, at some point in the problem, you're going to be distributing a negative through multiple things over here. Sometimes those things have to be distributed, and you've got to pay close attention to that negative and make sure that it ends up where it needs to be. That's going to be the trickiest part about these. Alright, so let's see if we can get these to factor. Alright, that's going to factor as x plus 3 times x plus 3. And over here, we'll have, these are all additions, so you're going to want to use 2 and 3. Okay. There is one significant piece of this that we've got to pay close attention to. We've got x plus 3 times x plus 3. You could think of that as x plus 3 quantity squared. If you remember when I told you about the LCD and how to find it, I said that you would need to include any powers of a factor that you might encounter. So the x plus 3 is just, is x plus 3 squared. Alright, so that means our LCD will have to include x plus 3 quantity squared. What else needs to go on my LCD? What other factors do I have? This denominator has the x plus 2, and then it has the x plus 3 again. So we need to include the x plus 2. Okay. That x plus 3 is okay. It's going to stay right where it is. We do not need to put another x plus 3 in our LCD because we have x plus 3 squared already in here, and it includes that factor. So we just need the x plus 3 squared that we had here, and we need the x plus 2. And you're going to have to excuse me while I go tend to my baby. He just woke up. But hopefully he's down for a little bit longer. So we had found our LCD to be x plus 3 quantity squared times this x plus 2. So we can now rewrite this entire problem as a single fraction with the LCD, and we'll work on making the numerator and turning it into our equivalent fraction that we need. Okay, so we got a big fraction. Here's our LCD. Alright, the first fraction, what is it missing from the LCD? Well, the LCD has an x plus 2 factor, so I need to put the x plus 2 factor into this numerator. Again, if there's anything that you are not understanding, please, please, please let me know in class. Yes, we have a pretty large class. There will be a lot of people in there, but I'll be making my way around trying to talk to everybody. So just let me know if there's anything that you're struggling with. Over here, what are we missing in this denominator? There should be another x plus 3 factor, because we should have x plus 3 squared. So we need to multiply the numerator and the denominator by the extra x plus 3. So I need to have parentheses. When I put this all together, this binomial absolutely must go into parentheses so that we know how to distribute our negative here, because it's got to be distributed to both terms. And then we also need to multiply this by the x plus 3 factor that was missing from the denominator. Okay. So, let's start distributing that numerator. We've got x squared plus 2x. Alright, I'm going to go ahead and write my LCD in so we don't forget about it. Okay. Alright, so we've got x squared plus 2x, and then this is where I told you that you have to be super careful with distributing this negative. My recommendation is to just leave it as subtraction now, and I'm going to put like a square bracket and go ahead and FOIL these two factors inside the square brackets, and then I'll come to another step and then distribute that negative. Alright, so we'll FOIL that. That'll be x squared plus 3x minus 3x. Those middle terms are going to cancel out. Notice these are conjugates. And then negative 3 times 3 is minus 9. Alright, and now I can distribute my negative through here. So I'm obviously out of space. Why don't you go ahead and pause the video and see how far you can get from here while I erase, and then we'll finish it together. This is where we left off. Let's go ahead and distribute the negative into the brackets now. So we got x squared plus 2x minus x squared plus 9. And I know it's redundant to have to keep copying this LCD, but you don't want to forget about it at the very end of the problem. So you've got to be careful that you keep up with it. Don't just, it's tempting to only work on the top line, but if you forget that denominator, that's a lot of points that you're losing, so you need to keep it. Going back up here, x squared minus x squared, those cancel out. I'm left with the 2x plus 9. Alright, do you think you could do anything else to this? Not really. There's nothing that, this numerator does not factor. There's nothing that can come out of these two terms, and it definitely does not reduce with anything in the denominator. So this is as far as we can take it. This is our answer. 2x plus 9 over x plus 3 quantity squared times x plus 2. Well, apparently that was the last problem of this section. I didn't realize we were finished with it already. Make sure that you don't forget to do the quiz in my math lab before you come to class. Come in ready to practice and ask questions, and we'll be working on these together. Alright, I'll see you in class.